Alright, so today we're going to look at simplifying square roots, simplifying radicals, whatever you want to call them here. They mean the same thing. We tend to use simplest radical form when we're simplifying these square roots. So just a way to rewrite these. Now we have the square root of 48 on the left. 48 is not a perfect square, but we can find perfect square factors of 48. So when I simplify square roots, what I want to do is I want to split this up into two different square roots. I always like the perfect square factor to be on the left-hand side to make it easier when we're simplifying. So I'm looking for, again, a perfect square that goes into 48. I want the largest perfect square. Yes, 4 and 12 could work, alright, but 4 is not the largest. So if I were to keep dividing my perfect squares, I would find out that 16 times 3 equals 48. So my perfect square on the left-hand side, square root of 16. Whatever's left on the right-hand side, square root of 3. Then I look to simplify here. The square root of 16 is 4, all right? And the square root of 3 cannot be simplified. That just stays as square root of 3. So again, I broke up square root of 48 into two factors. One of them was a perfect square, the largest perfect square that goes into 48. And I simplify that perfect square, so the square root of 16 is 4, leaving me with 4 square root of 3. Another example here, 3 times the square root of 50. Now I'm going to kind of forget about this 3 for a little bit, okay, but the 3 is being multiplied to the square root of 50. 50 is not a perfect square, but I can split up 50. Again, I want my perfect square on the left-hand side, whatever's left on the right. If I'm dividing 50 by my perfect squares, I notice that 25 times 2, where 25 is a perfect square. 25 can be simplified, for the square root of 25 can be simplified to 5 times the square root of 2. That gets brought down. And I have to remember, I can't forget about this 3 here. So what do I do with this 3? It comes down, and we said that it was being multiplied to the square root of 50. So right now it's still being multiplied by whatever's in front of the square root sign. So we have 3 times 5, giving us 15 square root of 2 as my final answer. One way to check my answer to make sure I simplified correctly, maybe not picking the biggest perfect square, but I can plug my original into my calculator, and then I could plug the final answer into the calculator. They should give me the same decimal. I do want to show you what happens if I were to take the square root of 48 and maybe not pick the biggest perfect square. Maybe I picked 4 and 12. The square root of 4 is 2 times the square root of 12. I would have to look here and realize that 12 can be broken up again into 4 times the square root of 3, making this 2 times the square root of 3. Very similar situation to the one on the right. This 2 gets brought down 2 times 2, which is 4 square root of 3. So you can take a perfect square, but taking the largest perfect square simplifies the amount of work that you need to do to get to your simplest radical form. So hopefully this helped you guys, and thanks a lot.